Hi guys, get excited seniors. This is the last lesson that you have to learn in pre-calc honors of this year, 9.3 hyperbolas. Underclassmen, sorry you're stuck with me a little longer, but my seniors, this is it, so pay close attention. I know you guys are missing me terribly today, but today, the last thing we're talking about is a hyperbola. And by definition, a hyperbola is a set of all points in a plane that the difference whose distance from two distinct points is the foci. It's a positive constant. Okay, guys, what a hyperbola is like a mirrored parabola, you can say. So go ahead and write that down. It's a mirrored parabola, as some of you all say. If you notice here, you have kind of like a parabola shape here, and it's mirrored right down here. Again, like with our parabola, it opens towards the focus. So the focus is like inside the bowl. These pieces here of your parabola are called branches. So you can tell like which direction the branches open. You can tell how wide they are in regards to their graph with the asymptote and stuff like that. We'll talk about that in a second. But these are called branches. You're going to have hyperbolas that open upwards, these are our vertical. And you're going to have some that opens sideways, which is our horizontal. So that should make sense. If it opens up and down, it's vertical. If it opens left and right, it is horizontal. All right, the graph of a hyperbola is two disconnected parts called branches. We just talked about that. And there is a line that goes to these two branches are your hyperbola. And there's foci on there. We've talked about that with our other things. You have a foci, and it also intersects the hyperbola at 2 points called the vertices. So if you notice, there is a lot of information on this line right here. I'm going to highlight it. Let me grab a highlighter. I'm going to highlight this right here. Do you see all these dots that are on? There's a lot of information on that line. That is called the transverse axis. As soon as we figure out the transverse axis, you will know if it is a vertical or a horizontal hyperbola. You will have a center, which we're always trying to find our center. That's going to be our H and our K. And then you have vertices, which are going to be on our branches. And then you're going to have foci, which are going to be inside of our bowls. And once we figure out that information, you will know if it's a vertical or a horizontal hyperbola because all the major information is located along that transverse axis. So I know you guys look at this and you're like, wait a second, what's going on here? Okay, let's just digest it. This is a horizontal hyperbola. Do you see the red branches right here? They open up on the x-axis. That's why it's a horizontal. If you notice on this horizontal hyperbola, we have the foci, we have the vertices, and you have the center. All of the major information that you guys need to know is right here along this horizontal transverse. You have something called covertices. Those are the ones that, as we kind of say, aren't as important. They're on the opposite axis of where your transverse is. But if you notice here, we have these dotted lines right here. Those are asymptotes. You guys have seen asymptotes before. But asymptotes in our hyperbolas tell us how wide or how skinny to make our branches. They're those imaginary boundary lines that your hyperbola is going to get really, really, really close to but never touch. So if we go over here to the right-hand side, and I see here I have an upward and a downward. It's opening up and opening down. That's why it's a vertical hyperbola, because it's opening up and down. And if you notice, all of the important information is along this vertical line. So once you guys get some information, you can understand like, oh, okay, I see. Once you see the visual picture of how this opens, it's very, very, very simple, I promise. But what we're going to do is we're going to learn how to decipher all of this information, and we're going to learn two little equations for our asymptotes, and then we're going to be good to go. So if I look here and I see the standard form of hyperbola, It depends upon where the information is, okay? When you are given the standard form of a hyperbola, you don't worry about which A is bigger. Whatever comes first is whatever your transverse is, and we'll talk about that in a second. But your standard form is pretty much the same of everything we've talked about. Your horizontal has x minus h squared over a squared minus y minus k squared over b squared. The difference of an ellipse and a hyperbola is that middle sign. And the way that you can tell if something is, like I said, vertical or horizontal is by what comes first. If it is horizontal, your x value will come first. Don't worry about that y is bigger or smaller or anything like that. That doesn't apply to a hyperbola. If x comes first, it's horizontal and it's positive. We'll talk about that in a second too. But if y comes first, then it's vertical. We need to worry about the sign in the front here, and you'll see an example in a second, because the middle sign needs to be negative. And we'll switch if need be. We're also going to talk about A, B, and C. And those values were all very important when we talked about our ellipses. And they all have special meaning. A is the distance between your center and the vertices, or say vertex, because you have more than one, but there's vertices. B is the distance between center and co-vertices. And then C is the distance between center and your foci, or focus. Since there's two of them, we say foci, that's why. So it's center and foci. And with an ellipse, when we had to find our C value, it was C squared equals A squared minus B squared. In a hyperbola, it's different. It's C squared equals A squared plus B squared, which you guys are familiar with the Pythagorean theorem. But that's going to be some really helpful information for you guys to hang on to, write down, make sure that you're aware of, because this is super duper valuable. Again, here's just a visual of the standard form of an equation of a hyperbola. When x is first, it's going to be the transverse, where all of the major information is going to be on the horizontal. And when y is first, where all of the major information is going to be on the vertical. So it's easy to kind of see that there. If they ever give you the length of the transverse and say that the length of the transverse is 2a, you just say 2a equals. If they tell you the length of the conjugate is 2b, then, whatever, you can just say 2b equals or 2a equals. But the formulas are extremely, extremely, extremely similar to an ellipse. The only thing that's different is there's the minus sign in the middle instead of a plus. What you do also notice is that they're both set equal to 1. So if that's not 1, we're going to divide through and make it 1. So just say they gave us this, and they said, okay, find the standard form of the equation of a hyperbola with foci, blah, 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 and vertices, blah, blah, blah. Okay, so you guys are thinking like, wait, what? How in the world? First thing we do, to be the easiest, to be the smartest thing to do, is to draw a picture. So I'm going to say, okay, I have a foci at -1, 2. So let's just draw some. Might be helpful to have some graph paper. I'll have some available for you for your test. But -1, +2. And then I have foci at 5, 2. So 1, 2, 3, 4, 5, up 2. These are my foci. I'm going to call them F's. Remember, our hyperbola is going to open up towards the foci. So think about that. Already visually, you should know, oh, this is going to be a horizontal one because it's opening left and right. But again, if you don't see that, no big deal. All right, so let's plot our vertices. I'm going to do that in red. So one of my vertexes is at 0, 2. So 0, 2, that's a vertex. And then I have one at 4, 2. 1, 2, 3, 4, up 2. That's my vertex. So in order to write the equation in standard form of a hyperbola, you need the center and you need your A and B. So once we know the center, then we can figure out like where everything else is from there. But just this little visual, we can see all of the major information is along what kind of a line? A horizontal. So we know that we are dealing with the equation x minus h squared over a squared minus y minus k squared over b squared equals 1. That's super important information. Now, if you're trying to find the center would be right here somewhere in the middle. The center is just going to be the midpoint of the vertices. So you can either eyeball it by your drawing, or you can actually mathematically find it and say, okay, here's my vertices. So to find the midpoint, 0 plus 4 divided by 2 is my x value. 2 plus 2 divided by 2 would be my y value. So 4 divided by 2 is 2. 4 divided by 2 here is 2. So my center of my hyperbola is going to be at 2, 2. So I'm going to put that point right here at 2, 2. So I am going to draw a quick picture, and it's going to look just like this. Move to the right and to the left. How do I know it's shaped like that? Because, again, all of our information is along that horizontal line. And secondly, I know that because your hyperbola is going to open towards the foci. Your focus on each side is going to be inside the bowl, so it's a horizontal. So now let's find, because in order to write the equation, we have to have our center, which we have. This is my H and this is my K. And then I have to have my A and my B. So let's figure out what that is. Remember, your A is your distance from the center to the vertices. So again, you can either count or you can mathematically figure it out. But how many spaces did I go from here to here? So my A value would be 2. Your B value is from the center to the co-vertices. Well, I mean, did they give us any information about a co-vertex or anything like that? No. Okay, so let's just go along and see what else we have. Our C value is from the center to the foci. So I know my center is here, and I know my foci is here. So if I count, I went 1, 2, 3. So my C value is 3. Do I know a formula or an equation that can give me the value of B? Absolutely. I know that C squared equals A squared plus B squared. So I can say 3 squared equals 2 squared plus B squared. 3 squared is 9, 2 squared is 4, whoops, plus B squared, subtract 4 from both sides, and B squared equals 5. So my B would be the square root of 5. So we figure that information out super easily. Now, if we're going to write the equation in standard form, I would say x minus my H value is 2 of my center squared over my A value squared. Well, A is 2, so 2 squared is 4. Minus, I have y minus k, which in this case is 2 again, squared over. My B value is the square root of 5, so if I square the square root of 5, it just becomes 5. And then I have equals 1. And there, folks, is our equation of our hyperbola in standard form. If you were asked to graph that, we kind of already did that, in a little handheld sketch here. But if you're asked to do it with graph paper, you would do exactly what I just did. It'd probably make it easier for you because you wouldn't have to draw your own picture. All right, we come to this slide, and it's talking about asymptotes. You guys have heard about asymptotes in different stuff that we talked about with rational expressions and stuff like that. But an asymptote is just a boundary line that your graph gets really, really, really close to but doesn't touch. So it just helps you draw a better picture, when you're graphing and that sort of thing. It's an equation of a line. It's in y equals mx plus b. And if you drew a box around your co-vertices to your vertices, if you connected the dots, it would make a nice pretty rectangle inside. Some of them are smaller, some of them are a little bigger, but it would make a rectangle inside. We're going to talk now about the equation of our asymptote hyperbolas. If you have a horizontal transverse axis, this is the equation that you use. Y equals k plus or minus b over a times x minus h. The only thing that changes here is the a and the b and the b and the a. If you have a vertical transverse axis, this is the equation that we use. So we're going to do some examples here where we switch. We go from up and down to left and right, and we find our equation of our asymptotes to better draw our picture. All right, so it says to sketch your hyperbola. Okay, well, we got a lot of stuff going on here. First thing I need to look at is, wait a second, this is not in standard form. Why is it not in standard form? Because that's not equal to 1. So the first thing I'm going to do here is divide everything by 16. 4 divided by 16 leaves me with x squared over 4 minus y squared over 16 equals 1. Okay, we're in standard form now. We're good to go. This is our standard form, but it asks us to sketch the graph. That means we have a lot more things that we need to do here. First thing I'm going to do is say, okay, wait a second. We're starting off with x squared. Don't worry about which number is bigger. It's which number you're starting off with, which variable that's squared, that's positive, you're starting off with. So since I'm starting off with x squared, this is a horizontal hyperbola. So I know that all of the information is going to be from left to right on my horizontal transverse. So I know my center, it's going to be whatever's added and subtracted to x squared. There's nothing, so it's going to be at 0, 0. My h and k are 0, 0. That's pretty spectacular. I know that my a value is this squared. So a, if it's 4, a squared equals 4, my a value is 2. I know that my b is right here. B squared is 16, so that means b equals 4. So if we're going to find out what c equals, we'll say, well, c squared equals a squared plus b squared. So c squared equals 2 squared plus 4 squared. 4 plus 16, I get c squared equals 20. When I take the square root, I get 4 times 5, so I get c equals 2 root 5. So my c value is 2 root 5. Now that's going to be helpful when we try and find the vertices and the co-vertices and all that stuff. And we'll talk about that a little more, especially when I get back to school next week. But I just want to focus right now. We'll work on graphing, but I want to focus right now on how to find all of this stuff. So if they asked you to tell, if a question was, okay, write in standard form and then tell me the vertices. Well, think about this. Your vertices, we talked about this, your vertices are going to be along the horizontal line. So if your center is at 0, your a value is the distance from the center to your vertices. So if my a value is 2, I'm going to go to the right 2 and put a vertex, and I'm going to go to the left 2 and put a vertex. So my vertices are going to be at negative 2, 0. Oops, not negative 20. Negative 2, 0 and positive 2, 0. Your b value tells you the co-vertices. So that means I'm going to go up 4 for my co-vertex. I'm going to go down 4 for my co-vertex. So my co-vertex is going to be at 0, negative 4, and 0, positive 4. And then to find the foci, well, your c value is the distance from the center to the foci. And since our center is at 0, 0, I'm going to go negative 2 root 5, 0, and I'm going to go positive 2 root 5, 0. And then if you were asked to do your asymptote, well, we have our asymptote. Our asymptote equations are very similar. It just depends if you have a horizontal or if you have a vertical. Since we have a horizontal, I know it's horizontal because x came first. I'm going to say y equals k plus or minus b over a times x minus h. So my k value is 0, plus or minus my b value is 4, over my a value is 2, times x minus 0, because my h is 0. So if we simplify this, guys, this is 0 plus or minus 2 times x. So you have asymptotes at plus or minus 2x. You would graph those two lines, and we'll talk about this more, like I said. We'll talk about this more when I'm there in school, but it'll be like this. And then your hyperbola would look something like this. And again, we'll talk about this more when I am there. But it's all about right now mathematically finding your way. But we'll talk about graphing next week, Monday, Tuesday, Wednesday. These have begun to be my favorite problems. I used to get to completing the squares and be like, oh gosh, I hate doing this. But guys, we're getting so good at this, so it's great. You want to complete the square when you have variables that are squared. So in our ellipses and in our hyperbolas, we both have things that are squared. So let's go through the motions and do what we need to do. We're going to collect all of our x's, collect our y's, and be done with it. So I have 4x squared plus 8x plus my box. This time I have a minus 3y squared. 16 has nothing, so we're going to move it to the other side, so it equals negative 16. Okay, so when we complete the square, we want our a term to be a positive 1. It is not, so let's see. Can I factor anything out of 4x squared and 8x? Yes, I could take out a 4. Then I'm left with x squared plus 2x, and I can complete my square here. I take my b term, and I say 2 divided by 2 is 1. So I know that my binomial is x plus 1 squared. Since I took out that 4, it has to come down here. So when I say 1 squared, I have to take that 1 squared and multiply it by 4. So I get plus 4 here, and then I add 4 on this side. And when I look at the second term, I have minus 3y squared. I can't do anything with that. I can't complete a square because there's no other term to look at. So I'm just going to leave it like that for a second. And now I look at this and I say, well, wait, no. What should this be set equal to? This should be set equal to 1. So let me go ahead and divide everything here by negative 12. And let's see what happens. What is 4 divided by negative 12? Well, this becomes x plus 1 squared over negative 3. Negative divided by negative is plus y squared over 4 equals negative 12 divided by negative 12 is 1. Now, guys, remember, the standard form of an ellipse has a minus sign in the middle here. That's not minus, but if you look, this is negative. So I can flip-flop these two. I can rewrite this and say, well, y squared over 4 minus x plus 1 squared over 3 equals 1. And we are now in the standard form of an ellipse. Since my y value, y squared is first, I know it's going to be a vertical ellipse. I know that my a value is right here. A squared is 4, so a is 2. I know that my b squared value is 3, so my b value is the square root of 3. In order to find c, I can use that little tiny formula we have, the Pythagorean theorem. C squared equals a squared plus b squared. So a squared is 2 squared is 4, plus square root of 3 squared is 3. So c squared equals 7. So c equals the square root of 7. Okay, good. Yucky numbers, but who cares? We can identify our center here. Our center is at HK. Well, my H value is right here. It's negative 1. My K value is right here. There's nothing being added or subtracted, so I have 0 as my center. I already have my standard form of my equation. And if I needed to graph it, I absolutely could. I know that all of my information is on a vertical transversal. But if I had to find my asymptotes, well, guys, in this case, you have a vertical. So you have to use the asymptote equation for vertical, which is y equals k plus or minus a over b times x minus h. When it's horizontal, it's b over a. When it's vertical, it's a over b. So my k value here is 0, plus or minus a is 2 over the square root of 3 times x minus a negative h would be plus 1. Now, in this case, guys, we are not going to give you anything where you have to graph approximations with square roots. Any problems that I give you that you have to graph the asymptotes, it'll be a line that you're familiar with graphing. But you do need to know the difference between your vertical asymptote, which is a over b formula, versus your horizontal, which is b over a. Okay, guys, seniors, have a great time at prom. I'm looking forward to seeing pictures. Juniors, underclassmen, you guys can work on the practice problems. We'll work on them together Friday in class. Your homework for 9.3 is due Monday morning. We're going to go over it together in class. I'm going to give you guys a test review. You can work on it Tuesday in class. We'll go over your quizzes from yesterday, And then Wednesday we'll review, and Thursday we'll take our last test. So I hope you guys have a wonderful weekend. If I don't see you, if I do see you, I'll see you on Friday. And we'll talk later. Thank you.